Castro. It's like Instagram for space nerds. This video is sponsored by Picastro. It's like Instagram for space nerds. Well, good evening. Welcome to Space Oddities. Thank you for joining us on this Tuesday evening. Hope everybody is well. And I'm joined this evening by the usual suspects. Hello, Michael.
Hi there.
Hello, Lou. I hope you're feeling better.
Greetings. Yes, doing well, thanks.
Yeah, Lou's a new medical phenomenon because every time he goes anywhere, he comes back with COVID, which he's had again, despite being fully vaccinated and all the rest. But so we hope you're feeling better, Lou, and thank you for being here in your hour of illness, as it were. So
thanks so much, Andy.
There we are. We got Daz here as well, as you might guess.
Hello.
And Roger, of course.
Good evening.
Without which no self-respecting astronomy program would be complete, of course. So I'd like to give a big thanks to the guys for filling in for me last week. I'm sorry I couldn't be here last week. I actually somehow, for reasons completely unknown, managed to end up with a trapped nerve in my back. And for the last nearly 10 days, my back and my shoulder and my arm and my hand have been very painful. But I'm a lot better now. So apologies for not being here last week. I'm sure you didn't miss me, but there we are. So what have we got for you tonight? Well, what we've got for you tonight, believe it or not, is 20 years this week since the culmination of NASA's Deep Impact mission. So we thought we'd take a retrospective look back at that mission, which turned out to be quite an important one. I'm sure many of you are far too young to remember 20 years ago to the Deep Impact mission. So we will fill you in on that because it was an amazing mission. And contributed a lot to cometary science. So we've got that coming up. We've got, of course, the regular features. We've got Constellation of the Week. We have got Einstein of the Week. And also Lou is going to be telling us about his recent visit to AstroCon, which is a big astronomical, what do we call it, festival, I suppose, in the United States. And Lou is going to be showing us around that and what happened. So lots to get through tonight. Before we start, we have a big announcement to make. We discussed with you a few weeks ago, viewers, about how you might like to make regular contributions to Space Oddities in return for something. So we are pleased to announce that our Patreon page is now open for business. And the Patreon page, hang on, I'll just put the address up on the screen. Very, very easy to remember. It's patreon.com/Space Oddities. Very easy to remember. And if you join our Patreon page, which costs £5.50 a month plus VAT, unfortunately, £5.50 a month plus VAT, what you get is you get access to all the presentations that we feature on our Tuesday live streams, plus extra presentations that we don't live stream. We'll create those specially for you. And also, although we haven't built a library up yet, you'll get access to lots of Space Oddities videos that we've created. And you can download those and make your own collection of good Space Oddities content. If you would like to support us by becoming a Patreon member, then it's very, very easy. Just go to patreon.com/Space Oddities. And it's £5.50 a month. That is about the minimum we could set where we would end up with some money from it, because obviously Patreon take quite a cut for the privilege of using Patreon. So that's about the minimum we could charge, unfortunately. But £5.50 a month plus that, and you get access to lots of Space Oddities material. When you join Patreon, there are some chats there. There's a chat called Astro Lounge, where you can chat with us and each other about anything space related. So it is like a lounge. You can just, chat there. There's also a chat called For New Members. That gives you full details of how to download the Space Oddities material. It gives you a link to a folder where you can download it from the cloud. And there's some other chats there you might want to participate in. The best thing is, though, that we have a special present for you. If you become a Space Oddities Patreon member, then we will send you, completely free of charge, no postage, 2 wonderful 10x8 astro prints taken by our wonderful astrophotographers here, Roger and Tom. They have kindly contributed some of their images, and we will send you 2 of those in 10x8 size that are ideal for framing, completely free of charge as a little present for becoming a Patreon member. So head over to patreon.com/Space Oddities and join the community. And we do want to get a community going there where you can ask us questions, communicate with us. You can there's a feedback chat there where you can give us your ideas and thoughts and likes and dislikes, etc. Suggest things that you might want to see on the channel. So lots to get your teeth into there. So that is now open for business, and we hope to see you there as a Patreon member. And thank you so much for your support, because obviously having a regular income for Space Oddities helps us a lot to put things on a firmer footing going forward. So thank you so much. If you want to become a Patreon member, you have our eternal gratitude. So that's that.
Just a quick point, Andy. Lou and myself have also put some
have you?
images up. So yeah, you're going to get lots of C-star images.
Lots of C-star images.
in amongst the professional stuff.
In amongst the other stuff. So we will send you 2 images each, potluck, because we'll have quite a selection. But you know, they are 10x8s. They're good quality, and they're ideal for framing. So we hope you will become a Patreon member, because it really does help us moving forward. And thank you so much for your support. So yet again, patreon.com/Space Oddities is where you can go for that. What else? Well, obviously, as well as that, we've got the usual merchandise. So don't forget, one way of supporting us on Space Oddities is to buy us a coffee. And because after all, astronomers' lives matter. So you can buy us a coffee by either scanning the QR code or clicking the link that should have just appeared in the chat. And you can keep us topped up with caffeine that way. Also, of course, don't forget, it's the middle of summer, so you really want to get your Space Oddities t-shirts, and you can do so at the Space Oddities shop. And again, you can scan the QR code there, or you can click the link that's just appeared in the chat. And as usual, I have to say, every bit of money we receive from this, from Patreon, all of it, goes towards keeping Space Oddities running and paying the sometimes sizable bills that we have to pay to keep everything on the road. So thank you so much for your support, and you know that we appreciate you. It is much appreciated. Okay, well, what we're going to do now is we're going to talk on just a couple of things, because I haven't been very well this week, and I haven't been able to sit at the PC for very long at a time. I haven't put together any news for this week, for which I apologize. I will hold the news stories on over till next week, of course. One thing I did want to talk about, though, was the fact that we have a new visitor in the solar system. And this is a new interstellar comet. And the new interstellar comet has been detected by astronomers. It's definitely a comet. And let me just get some details of this up for you. And here we are. So it's this was recently detected. Hope you can see that. It's called 3i Atlas. And you can see a very, very, very pixelated image of it moving against the background stars there on the left. Now, this is an interstellar comet. It's the third one or the third object to enter the solar system that we know about, definitely, has come from outside the solar system because of its trajectory, if you like. Just a little bit of information about it. It's 20 kilometers across, so it's quite a sizable comet. It's at the moment, it's 670 million miles from the sun. It's very, very fast moving, 134,000 miles per hour, which works out to about 6 kilometers a second. This is very unusual for something to travel that fast through the solar system. And this is one of the reasons why astronomers knew that it was interstellar, because of the sheer speed of it. Also, it's not going to come that close to the Earth, unfortunately. It's not going to be very bright in the sky, possibly magnitude 10.8, 11, something like that. And it's going to reach its perihelion around the orbit of Saturn. In other words, it's going to start leaving the solar system again at about the orbit of Saturn. So it's not going to come extremely close to the Earth. Unfortunately, it'd be wonderful if it did, because this is obviously an object that is very interesting and worthy of much study. It has come from the direction of the galactic center, in other words, from, if you like, the direction of Sagittarius. But of course, it didn't originate there, probably, although we don't know exactly where it did originate. So this is a really exciting time. Of course, as I said, this is not the first interstellar visitor that we've seen, and we've seen 3 in recent years. The last one was Comet Borisov in 2019, and here's a beautiful image of Comet Borisov, another interstellar visitor. And before that, of course, we have the famous, or even infamous, Oumuamua, which has generated a lot of controversy because it's only about 400 feet long. It's sort of cigar-shaped, and as it was leaving the solar system on its way out, it appeared to accelerate under its own volition, which has led to lots of speculation that it's an alien spaceship, etc., etc. You can imagine what social media has done with this. There are thousands of YouTubes about the aliens who sent Oumuamua, all the usual nonsense. But it is still an enigma, because we don't know what it was. It wasn't a comet. It didn't have a tail, nor a coma. So definitely not a comet. It appeared to be a lump of rock, but it's very strange. And because it was on its way out of the solar system when it was discovered, we'll probably never know exactly what it might be. So there we are. So I just thought I'd mention those 3, the 3 known interstellar comets. But of course, there are probably many, many more interlopers from outside the solar system all the time. It's just that they are, or can be, difficult to spot. And we'll have to wait and see what we discover in the future. But of course, you know, why should the solar system be free of objects from outside the solar system? Space is, you know, peppered, if you like, with all sorts of objects moving between stars. So we'll have to wait and see what the future holds. Any thoughts on that, guys?
I have a couple.
Yeah.
So you put up some very interesting parameters for this new interstellar comet.
Yeah.
And I just wanted to tell our viewers how that kind of data is arrived at. One of the first things that they have to do is get a distance. And the distance can be done a number of ways, including parallax, right? It's close enough for parallax measurements. So when they believe they have a distance, then you have to make an assumption about the quality and composition of the surface of this object, because we can't really see it, as we saw in this very grainy image. So when they do that, when they say, okay, we suspect that the surface is made of this and perhaps has this kind of roughness or smoothness, then they can get an albedo. They can get a reflectance from it, right? How much light from the sun is reflected, how much is absorbed. Once that's done, then they can say, okay, if it's made of this and it's reflecting this much light, then we know how big it is. That's where the 20 kilometers came from, I'm pretty sure. So it's a bit of a guess, but anyhow, it's based on that kind of information. The other thing I wanted to say is that now, and I'm not sure, is it Oumuamua or Oumuamua or whatever the whatever the
Well,
image.
it sounded a bit like kissing to me. So being the old romantic that I am, I always say mwah, mwah. So
Well, not the way I kiss, but anyhow, moving forward.
too much information, Lou. Too much.
Yeah. The acceleration, I believe, has been explained by modeling solar radiation pressure.
Right.
Right. So that when you take that into account, then you don't need any special mechanisms for accelerating this object. It's all very natural.
And also, it was like shaped like a sail, wasn't it? So they reckon that it was actually the like you say, the solar wind pressure was used as it was basically acting as a sail, which gave it the acceleration. But yeah, of course, Vera C. Rubin, she'll be the telescope. They'll be picking up lots of objects like this in the southern hemisphere. So
very good point, Baz. I mean, you know, for goodness sake, it discovered over 2,000 comets in not many hours.
Yeah. And I know me and you have spent quite a bit of time on the comet spotting. So.
Just before I forget, remember we were talking about citizen science 2 weeks ago? Well, I'm pleased to report that the first citizen science project using the Rubin data is now active. It's called Comet Catchers, and you can find it by going to cometcatchers.net, and you can plow through the Vera Rubin data trying to spot comets. And Daz and I have spent probably
too much time,
stupid amount of time. But I seem to find lots of comets in the Rubin data. Did you?
Yeah.
This is
once you learn how to use the tools, which only took about sort of like 5 or 10 minutes.
Yeah.
And you start looking at them, you can pick out the tails quite distinctly.
But the question
there's
me,
a hell of a lot of comets.
Are these comets the 2,000 plus that Rubin discovered? So are we looking at ones that have already been discovered, or are these new ones that we're discovering? This is what I want to know.
Well, some of them are already discovered because they use them as confirmation. People know what they're looking at. If you do pick one, and of course, like I said when we were talking about this last week in Citizen Science, you're not the only one who's seen that picture. So there's people who are confirming what you've seen.
Yeah.
Again and again and again and again for confidence in the actual fact that you can see it. Some of the tails are very faint. This is where you change between the images, so you can actually see. You can invert so instead of being a black background, it's a white background, and the stars and everything else is dark, so you can actually see a very faint tail coming off them. And there's also another one to start with. It's the same as the Webb, and that's galaxies interacting with each other. It's like Galaxy Zoo. All these fainter galaxies and things like that, they're going to give you a chance to classify them. And I must admit, I have been on that, but that's quite hard, actually. That one is quite a hard one. So it's not one you can rack up your finds. Let's put it so I doubled my finds within sort of like 2 hours. So
I mean, I was quite amazed how many comets there were in the Rubin data. I was also really impressed that they got that up and running so quickly.
Yeah.
As a project. So just to put that up on the screen, you can find it at cometcatchers.net, but it's part of the Zooniverse umbrella.
Right, yeah.
So you can go to zooniverse.org and look at the space projects there, and you'll find it. And happy comet hunting.
It's so. As I said, it should come with a government health warning.
Yeah, it should. Yeah, I stayed up to 4:30 one morning.
Yeah, I mean, it's a case of that.
10 minutes.
Yeah, there are so many there that you're finding them every 2 or 3 pictures.
I know.
So, and you just want to find one more before I go to bed. One more.
Yeah, that's right. I know.
Before the next thing you know, Halley's Comet's here again.
Yeah. It's like we're astronomers. We stay out all night. And we think, I just have another 10 minutes. I'll just look at that object. And then suddenly there's this big glow in the sky to the east. And you think, oh, it's morning. You know?
Always looking for heavenly bodies.
Yeah, well, you'd know about that. So anyway, cometcatchers.net. Go and find some comets in the Rubin data. I think this is all fantastic stuff. I never dreamed when I was younger that we'd be able to do this to make contributions towards science and astronomy, and it's all free, of course, and full instructions are given on the site, of course. So there we are. So that's Comet Catchers. There will be, as Daz said, a lot more projects based around the Rubin data in the coming months and years. So there we are. Fantastic stuff. So we got another cometary visitor from outside the solar system. Sorry, Lou, was there anything else you want to say about that? Did I interrupt you?
Oh, no, not at all. No, that was everything.
Okay. So, but as we saw in that very pixelated image of it, it's it's not going to be a bright object. It's just not. But perhaps a reserving challenge for somebody. So
yeah, I mean, because of its speed. Where is it, in the north or the southern hemisphere? Do you know? It's been.
Ooh, I think it's in the northern, actually. Well,
I was just going to say the Vera Rubin. You'll be able to pick it out because you'll get the red, green, blue dashes where it's actually moved as they've taken the three filter images. So that's
well, Roger, I don't suppose that comet has cropped up in your data for the night sky, has it?
No, not yet.
Not yet. Oh, right. Okay. Well, we'll have to wait and see. All right. Let's move on. So what we're going to do now is we will go straight over, actually, to Roger. And Roger very patiently every week puts together what we can see in the night sky. And, of course, the viewers gallery. Have we got a good gallery this week?
We've always got a good gallery.
Well, yes, but in terms of quantity, you know what I mean. So, so let me just put that up on the sky, and then we'll go. I seem to have lost my mouse.
Yes, I put some of the other members' pictures in as well as mine.
Oh, right. Okay. Very generous.
You're so good
to Roger's gallery. I mean, the viewers' gallery.
Yeah. To viewers' gallery. Just give me a second. My mouse is doing weird things. So where are we? So okay. So take it away. Oh, sorry about this. I don't know if the battery's going on my mouse, but my mouse pointer's lagging a bit. Okay, not to worry. Okay, take it away, Roger.
Oh, this is what happens when Andy's been away for a week. I don't know. He's forgotten half the stuff. Right, so we are through getting on towards the middle of July already. So should be quite interesting what we've got coming up for you this week. We're coming up through to another full moon on Thursday, which will be the buck moon.
The buck moon?
The buck moon, by the Native American tribes, refers to the season when the male deer grow their antlers.
Ah, that's interesting.
Also called the thunder moon or the hay moon.
So the buck stops here.
Yes.
Right.
I mean, currently yesterday it only got to a high altitude of 11 degrees, so it's gradually starting to rise again. So shouldn't be too much of an interference, but there we go. So this week on the 8th and the 9th, we've got Venus going near to the Pleiades through this week. So that could be a photo opportunity for those that like to get up really, really early to get that before the dawn skies start to fade the stars away. So keep an eye out for that. And we've also got Mars and Mercury available to see before it gets too low down after sunset as well. So have a look. It might be a bit of a challenge, but good opportunity to get two planets to see during the evening sky. Have a look. So we've got Aquila coming up through part of the Summer Triangle, the last of the stars of the Summer Triangle coming up through. The other two are getting quite well established now. And there we go. So it was first catalogued by the Greek astronomer Ptolemy in the 2nd century for that constellation.
Wow.
So, should you wish to know that.
I did.
So we've also, yeah, right. So we've got Saturn and Neptune also fairly close together, although it will be a bit of a challenge with Neptune being a fair bit dimmer, but Saturn will be of interest again. It's still got very narrow edge on, almost edge on ring still. So, but it will be visible. So, an opportunity there for some more planetary imaging. And we're also getting towards the Southern Delta Aquariid meteor shower, which will peak later in the month. So keep an eye out for that. And obviously, with the sky starting to get a bit darker, we'll get a good chance from about midnight onwards to start to see the Milky Way core coming into the southern horizons to see what we can get capturing on that. So, brief highlights here. We've got Venus and the Pleiades on the 8th and the 9th. On the 10th, we've got the full buck moon on the 10th. A few days after that, we've got Mars and Mercury in the sky, just about. And following on from that, we've got Aquila coming out through part of the summer triangle. And then we've got the moon with Saturn and Neptune coming out through on the eastern skies as well. Okay, so another outstanding gallery this week. Thank you to all those that regularly contribute. And as usual, we've got Jerry Delay with the Dumbbell Planetary Nebula in Vulpecula. And he's got this as a reprocessed image with his usual Richie Critchon 6-inch scope and his 26 MC Pro and 30 times 5 minutes exposures. And this is what he's produced.
Wow.
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 Very nice.
The colouring's lovely, isn't it, on that one?
Beautiful.
Yeah.
Well done, Jerry.
Yeah.
Brilliant.
Very sharp image too.
Yeah, I was going to put my C Star one up, but I think I'll change my mind now.
Wow. Okay, right. And we've got one from Lou. Now this is done with a Galaxy Samsung S25 Pro. So not a C-Star, but a phone picture.
One step down from C-Star. This is just a cell phone.
That's lovely.
That's pretty good for a cell phone.
Pretty good for a cell phone, yeah.
Ah, that's nice, that is.
That's lovely.
Yeah, you've got some crater details as well there.
Yeah.
On the Samsung, as you increase the magnification, right? You're spreading the screen and increasing around 12x. They have a telephoto lens that takes over and produces these. Pretty
See,
good
the sea of space debris is there.
Yeah.
Right.
Yeah.
Yeah. So is that handheld, or did you put it on?
Handheld, yeah. I'm just sitting waiting for fireworks out here, and
Oh wow.
and I said, "Hey, there's the moon. I'll shoot it." That's it.
Yeah, why not?
Why not?
Because we can. Well done, Lou. And then we've got Daz with a C-Star picture of the moon, which was on the 3rd of July. So it's pretty much the same thing phase here.
Nice.
That's pretty nice. Okay.
You can't really tell the difference, can you?
I think the C-Star's image is a lot better.
Yeah.
I'm trying to be kind, Lou.
Oh, you're a good guy.
Okay. Well done, Daz.
Thank you.
And we've got some from Kevin Earp, which we haven't had for a while. And there's some nebulous pictures rather than some of his more interesting solar or lunar imaging. So we've got the North American Nebula, and this is 50 minutes integration per channel in a Hubble palette. So we've got 150 minutes, so 2.5 hours.
Oh, that's
And
nice.
this is, so he's got that in 2.5 hours. Oh,
That's nice.
very nice.
There's that dark dust in the foreground. It's lovely.
That's
Yeah.
beautiful. That is lovely. Well done, Kev. Another winner.
Outstanding.
Mhm.
Yeah.
And then he also got the Elephant's Trunk Nebula. Now this one's a little bit longer at 2 hours per channel. Same thing over 3 nights. So he obviously did 1 filter per night, and this is what he's managed to get.
Oh, that's nice.
That's beautiful.
Where is the elephant's trunk? I can't quite.
It's in the middle.
Right in the middle.
That's a.
So you got the top part of the nebula there is his head with his eye. Then you got the trunk which falls down, joining up the column coming up from the center.
Mm.
Does that make sense?
Yeah, I feel the poor elephant. Okay, I guess I see it.
Yeah, yeah. Okay.
Nice image though.
Very nice. Okay, so and an image by me. On the 6th and the 7th, during the daytime, we've got the sun in hydrogen alpha. So we've got some interesting activity here.
Mm-hmm.
Now the full disk was a 16-panel mosaic.
Yeah.
So,
yeah, if you look up in the northwest quadrant, you can see 2 lines. Now that's filaments. Now they're actually joined together, and they came a bit further over towards the east. That actually lifted off on the what we all know, the 8th now, so it would have been the morning of the 7th. That actually lifted off the surface.
Yeah. Okay.
Nice.
And then I've decided to go and do some deep sky imaging, but I just put my color camera on rather than doing it separately with red, green, and blue. So this is the Eagle Nebula, and it's 45 minute times 5 minute. So.
Oh
wow!
Gosh.
Lovely.
Wow, that's
So you
nice.
can see the pillars of creation.
Yeah.
Yeah.
Yeah,
Lovely.
that's really nice.
Then in the middle. Okay. And then the following night, I decided to do the dumbbell. So you've got my version. So we got two pictures of the same subject this week, and this is my version, which is 54 times 5 minutes at 200 gain with my 5-inch refractor, and this is what I produced.
Oh,
Ooh,
Wow!
nice.
Wow.
What a lot of stars!
what a lot of stars! Yeah.
Yeah.
Jerry's obviously used PixInsight or whatever to reduce the stars down, I guess, because I've got in thousands of them there. But there we go.
That's always been one of my
Lots of blue and lots of yellow stars in there.
yeah.
Yeah, lovely.
And you can start to see some of the extended gas coming away as well. So.
Yeah. You see a little halo around it, can you?
Okay. So that concludes the gallery for this week.
Oh, it's lovely. Well done, everybody. That was lovely.
Excellent.
Fantastic. Beautiful.
Right.
And that's it.
That's it for this week.
Okay. Well, thank you very much, Roger. That's a lovely gallery, but more to the point, thank you, viewers, for your contributions to the gallery. Don't forget, any contributions to the gallery, you also get your own little gallery on the Space Oddities website. It's,
yes, they are all up on the website this week's images already. So.
I was going to photograph the moon last night. By the time I got the camera ready, it was cloudy.
Oh, right.
Well, that's,
saw you coming, Michael.
Yeah.
So you can send your images in to the Space Oddities. You can email us your images, 1 image per email, please, and send them to gallery@spaceoddities.space. And you have our eternal gratitude. And as I said, not only do you get to show them to all the viewers here on our Tuesday live streams, but you get your own gallery on the Space Oddities website, with which you can impress, thrill, and excite your friends about your astrophotography efforts. And there we are. So keep the images coming in, because we do love looking at them, and we're always in awe of the skill that you all show in your images. It's a never-ending source of surprise to us how good your images actually are. and how much they're rivaling much bigger telescopes now, even with small and inexpensive equipment. You can produce some images that a few years ago would have been unthinkable from amateur equipment. So things are moving on, and we're very grateful for your support in keeping the gallery going, and we will keep it going, of course, as long as we have contributions. So, as we said, it doesn't have to be expensive equipment. It doesn't have to be deep sky imaging. If you've got a skyscape with something interesting in the sky, anything you'd like to share with us, really, send them into gallery@spaceoddities.space, and there we go. Okay. Talking about the Sea Star, one thing that I don't know about the Sea Star, which those of you who've got Sea Stars, so if there's for example, a new comet in the sky, does it automatically download the ephemeris for it so it can find it?
Yes,
it does.
Yeah. 'Cause I caught one of the free pictures that people can watch is on the Sea Star. It's a comet that I caught. I can't remember the name of it. It's one of the Swift ones, I think.
Right.
So it was about about 6 or 7 months ago. Yeah, it will come up, and you actually get a list at the bottom of what's available in the sky, and usually the comets are put in that because that's what people want to go to.
Yeah,
and they bring out the color lovely on them as well if there's any coloration in them.
Because when I bought my Meade ETX 90, which is 25 years ago now, gosh, I could update the computer over the internet, and this will tell you how old it was. It used a serial RS-232 link to connect the telescope to the computer.
Yeah.
Those were the days. I've still got the cable
now, Andy.
Yeah, I know. But I've still got it. I've still got my ETX. So there we are. Just going back over a couple of things. Firstly, Alan Lebry, really sorry to hear you've got sciatica, mate. That's very, very painful. I know many people that have it. Hope you feel better soon. And also, Alan says he thinks that the interstellar comet is currently in reticulum near the South Celestial Pole, so not visible from the Northern Hemisphere. So that's probably why you've seen nothing of it, Roger, in your data. So thank you very much for that. I don't know if it will be crossing into the Northern Hemisphere. We'll have to wait and see. But
perhaps that means Vera Rubin can see it.
Vera Rubin, yeah. But look, as
it has done already.
We don't know how long it's going to be in the night sky, though. That's the thing, because it's traveling so fast. And of course, they haven't started operations with Vera Rubin proper yet. They won't do till October. So I hope it's still visible in the sky in October. But traveling at that speed, it might not be. So we'll have to wait and see. But thank you for that info, Alan. Very, very useful. Right. So let's move on. 20 years ago, NASA launched a mission called Deep Impact to Comet Tempel-1. And I can't believe it's 20 years, but it is. So I thought what we'd do is just take a retrospective of that mission and have a look at that. So hope you can see that. If somebody could just maximize that on the screen to get rid of our ugly mugs. Thank you. So this is a retrospective celebration of this groundbreaking mission that happened 20 years ago. And it was an important mission, which I thought it was worth definitely having a look at. So the first question is, why study comets in the first place? Well, comets are really, they contain pristine material from the birth of the solar system 4.6 billion years ago. And understanding their composition is really important to understand the solar system and, potentially how life on Earth gets started. Because there's been lots of ideas about this theory called panspermia, that life can be spread throughout the universe by material on comets. But before Deep Impact, we really didn't know a lot about the actual composition of comets. There was a big gap in our knowledge. So this was an important mission to try and understand exactly what a comet is made of and how it behaves. So the objectives, I'll just go through this very quickly, to reveal the interior of the comet, studied crater formation, analyzed the composition, and it was actually the first real thought given to planetary defense. That is to say, if we were ever threatened by comets or asteroids, what could we do about it? And what NASA decided to do was basically slam an impactor into Comet Tempel-1 to see what happened, basically. And the impactor itself is shown here as a solid bit of copper measuring 220 pounds, designed to create the biggest crater possible on the comet. And it weighed 370 kilograms. And the orbiting spacecraft would take images of it and observe it from a safe distance, obviously. This was done on a shoestring budget, only 240 million pounds the whole thing cost. So this was a very, very cheap mission, which, you know, we're used to talking about space missions costing billions. Well, this was a really cheap mission for NASA to mount. So the timeline, launched on the 12th of January 2005. Didn't take long to get to the comet. It wasn't that far away. So it arrived at the comet on the 3rd of July 2005. So exactly 20, more or less exactly 20 years. The impactor was released. Took 24 hours to get to the comet and blow a hole in it. The impact happened on the 4th of July 2005. The impactor at the time was traveling at 37,000 kilometers per hour. So you can imagine that was a severe impact. But that wasn't the end of the mission, because in 2007, it was renamed as Epoxy, and for extrasolar planet observation and deep impact extended investigation. So it took on a new lease of life to do those things. It was then sent to another comet, arriving in 2010, Comet Hartley 2, and that was useful as a comparison between the two comets to see how they differed. And the mission came to an end in 2013 when contact was lost with the spacecraft. The impact actually happened on Independence Day 2005. The impactor collided with the comet at 23,000 miles an hour, releasing the energy equivalent of 4.8 tons of TNT. Happened 133 million kilometers from the Earth, and it was observed by both the flyby spacecraft and telescopes worldwide, as it says, in a perfectly choreographed cosmic experiment. And you can see the impact happening in the picture there. Here's a time lapse taken by the impactor itself as it approached the comet. And bang, obviously. And here's the moment of impact filmed by the flyby pair spacecraft. See the bright flash there that actually completely desensitized the camera because it was so bright. So what did we discover? Well, first of all, we discovered that the surface of the comet was a complex mixture of ices, dusts, and organic compounds. The surface of Tempel-1 was extremely porous and fragile, and at the time they said it was fluffier than freshly fallen snow. This was a real surprise because astronomers and comet scientists expected a much firmer surface, if you like. The fact that it was so fluffy was a big surprise at the time. Importantly, it detected water ice on the surface and beneath the surface. So there's a lot of water on the comets. Now, this goes back to that idea that perhaps one of the ways that the Earth got its oceans was that the water was delivered by comets. However, all the water we've discovered on comets is not the type of water that we get on the Earth. So far, we haven't seen any comets that has the same composition of water that we have on the Earth. So I think the idea that comets deliver the majority of Earth's water is losing favor rapidly. But we still don't know. It's still an open question where Earth got all its water. Another idea is that the Earth formed with a lot of water inside it, which came up to the surface. And you may remember a few months ago, scientists announced that they've discovered huge deposits of water inside the Earth. So it could well be that the Earth actually formed with water in it. And we've said before that the universe is absolutely full of water. So to have planets form with lots of water inside them perhaps is not so unusual. I'm sure Lou will have something to say about that, because he knows more about this sort of thing than I do.
Would you like me to comment now or later?
Yes, go on, please, now.
Okay. So what Andy is talking about is that there are different kinds of water on the Earth. There's the H2O that we all know about. But there's also something called deuterated water, or D2O. And that is the water molecule with just an extra neutron thrown in for the hydrogen atom. And it turns out that on Earth, in our Earth's oceans, the relative ratio of H2O to D2O is about 10 to the fifth, about 100,000 times more H2O than D2O. So then you say, okay, well, where did the water come from? And what you might like to do is look at comets and asteroids and things, and see if they have the same ratio of H2O to D2O, or what they call actually it's called the D to H ratio, deuterium to hydrogen ratio in these water molecules. And Andy's correct, we really haven't found the same ratios in comets, but we have found similar ratios in asteroids. And if you think of these small bodies, comets and asteroids being small bodies, as kind of a continuum from forming, far inside the freeze lines of water and CO2, like near the sun, and far outside the freeze lines of water and CO2 far away from the sun, and then they form all places in between. It's not unrealistic to imagine that there are objects that asteroids that formed with a fair amount of water ice in them. So I believe the current theories are that yes, a combination of outgassing from volcanoes and so on from the Earth, as well as asteroids. All right, I'll stop. I just wanted to say that.
Thank you very much, Lou. Also, they found organic compounds, including methyl cyanide and hydrogen cyanide, on the comet, which was interesting. And the surface, as we said, contained fine dust resembling talcum powder. And they weren't expecting this. As I said, they were expecting a much firmer, more rocky, icy surface. But the comet was covered in something as fine as talcum powder, which was a bit of a shock, really. The impact crater caused by that massive impactor was estimated to be 100 meters wide and 30 meters deep. So it really did make a huge hole in the comet. In the aftermath, the explosion or the impact produced this brilliant flash, as we saw, and a massive ejection of that fine dust that temporarily blinded the spacecraft's cameras. And don't forget, this dust plume contained material that dated from the origin of the solar system that hasn't changed since the origin of the solar system. So 4.6 billion year old dust that gave us a really, sense of our cosmic origins. And they reckon about 10,000 tons of comet material was ejected into space during the impact. The extended mission, as I said, epoxy, it had a second life, and it had the epoch component to observe stars with known exoplanets, to study exoplanets. And the Dixie was the component that allowed it to conduct flybys of additional comets. And as you can see, this is the one shown in the picture that it visited in 2010, Comet Hartley 2, which was a peanut-shaped object. And you can see these jets of carbon dioxide pushing it along, if you like, quite violent ejection of carbon dioxide jets. So it was a real, 2-for-1 mission, really. And considering it only cost a couple of $100 million, I say only, of course, it's all relative, but it was a cheap space mission that delivered a lot of science. The legacy of Deep Impact, well, it revolutionized our understanding of the comet's structure, proving they're more porous rubble piles than solid bodies. The organics found on it could have seeded early life with the building blocks of life, or not from that comet, obviously, but ones like it. Demonstrated the feasibility of planetary defense, which was later taken up by the DART mission, which you may remember we covered on the channel, that actually managed to change the orbit of an asteroid orbiting another asteroid, and it influenced the future missions to comets, like the famous Rosetta and the DART mission. So it had a really long-lasting impact and was a very, very important mission. In terms of public engagement, it really did capture the world's attention, and it was timed to impact on Independence Day in the US for the maximum public engagement. There were over 10,000 public events organized globally to watch the collision. More than 2 billion people viewed images of the impact, so it was seen by a lot of people. Inspired the Citizen Science Small Telescope Science Program, and the principal investigator of the mission, Dr. Michael Ahern, said Deep Impact has completely changed what we thought we knew about comets. So a fantastic mission. And if you have any memories to share of that mission, please do put them in the chat, because it was quite a landmark mission. Anybody else want to say anything, guys? Anything to add about that mission? No.
Might I just add that I worked with Mike Ahern for a number of years on the planet. When planetary data is collected, it has to go somewhere, and there's a distributed network on the ground called the Planetary Data System. And in Europe, it's the International Planetary Data Alliance, I think, and they collaborate.
Mm-hmm.
But anyhow, Mike was head of the small bodies node at the University of Maryland for the Planetary Data System. So not only did I work with him on that as I was a part of the PDS, Planetary Data System, but I took a course from him in college as an undergraduate.
Really?
So he was a great guy. He was a really substantial contributor to our knowledge of the solar system.
Is he still with us? Do you know, Lou?
No, he's not. He passed away, I think, in 2017. I want to say.
That's a shame. I go say, because he might have been an interesting guest to chat to on the show.
He would have, although I'm still in touch with the PDS. I could we can talk about getting somebody else from PDS or the small bodies node if you want.
Yeah, that would be interesting if you could do that. Thank you. That'd be great, because I think we forget some of these missions. There've been so many space missions over the years, and Deep Impact was one that was really a game changer in terms of our knowledge of comets. So it's nice to look back on these missions. Viewers, if there are any space missions that you would like us to do a retrospective of, to look at again, that you think would be interested in, then please put it in the comments, or of course you can always email us at info@spaceoddities.space, because these things sometimes are easily forgotten, and from the science point of view, it's really useful, I think, to look back at where we've come from, because cometary science has moved on a lot since Deep Impact, mainly thanks to Rosetta, which of course was an incredible mission and told us, I think, more about comets than we'd ever known before. Perhaps we'll do a Rosetta retrospective as well, because there we are.
That was an unintentional impact.
Yeah. Wow.
But it is, yeah.
Paul says it was a brilliant mission, and I remember seeing the scientists being shocked by the size of the collision. That's right, Paul. I think I remember that. I think everybody was. I don't think they expected such a huge explosion, as it were, a huge impact. It was completely unexpected. So So, I mean, lots of surprises. Talking of impacts, of course, the DART mission with Didymos. You know, we thought that we might be able to change the trajectory of the asteroid, but we actually changed it, but by a lot more than we thought we were going to. So these things are often really surprising. And of course, the day that astronomy stops being surprising, I think the time I'll lose interest in it, because you never know what's going to happen next. And that's what makes it such a wonderful interest to have, in my opinion. And yeah, Paul says quite rightly, it was so ambitious, I couldn't believe it worked. So absolutely. I think everybody was shocked at the effectiveness of the mission. Considering it was so cheap, we ought to do more missions like that, definitely. So yeah, thank you, Morgan. He says very good, and there we are. Okay, where have we got to now? Let me just have a look. It's time now to go over to our regular feature of Constellation of the Week. So we're going to.
Are we going to do Lou's AstroCon first?
Yes, we could do.
Can I do the Stardust, Andy? Because it's a follow-on from your.
Oh yes, sorry, there is a follow-on to Deep Impact. Yeah. Sorry, yes, I'm getting ahead of myself.
Yeah.
Yes,
he's lost 1 week off and he's lost the plot, lads. I think we were sending back to the retraining, have him reprogrammed.
I've got a painful shoulder at the moment that is telling me to give up, and I won't. Yeah. I will persevere.
Okay, so well, I'll quickly run through this for you because it's only a very short.
So tell us about Stardust then.
Yeah. Right. Well, Andy's excellent presentation telling us about the Deep Impact and how it was then rescheduled and renamed Epoxy to visit a second comet. Well, after this is all over and done with, they decided that they had a probe already that was launched before Deep Impact even launched. A mission called Stardust, which was not a impact mission, but it was to collect dust from comet tails. And what it did, it was targeted comet Hartley 2. On its way to Hartley 2, it passed an asteroid called Anne Frank, 5535 Anne Frank, which it took images of, which had never been they'd done before. So what they did is then it went to did its mission and it collected the dust from Hartley 2, and then they said, well, this has still got quite a bit of fuel on board. Let's do a second mission with it. And what they did is they came up with the new exploration of Tempel-1, which they called Next. And what they did is they redirected it back to Tempel-1, and it arrived. Now, your impact was in 2005, wasn't it, Andy?
Yes.
Yes. Well, it arrived in 2011. So this is 6 years later, to basically to have a look at the actual object of Tempel-1 again, and to see what had actually happened to the crater. So what they did, this is it arriving at Tempel-1. It's still quite some distance off, but it's a lovely image of this this comet. And then what it moved on, and then it came even closer. And what we saw, and you've seen this image already because Andy's put it up. This was the image on the left is from before Tempel-1 impacted, and this is the image afterwards. And as you can see, it's very hard to see. And what they put this down to is the fact that all the material that had been evacuated from the surface and out into the air had fallen back down and virtually filled the crater site. It's quite a fuzzy picture, but you can just see there a small round feature, and it's arrowed so you can to help. But yeah, that's what they actually saw. And as regards, as you were saying, Andy, with them finding that this is all loose material, it's something we found with other missions to asteroids and to comets is that the fact that they are loosely made. Then we think that they're hard surface objects, but they are loosely made, and they're sort of like honeycombed with different sized boulders, different size. There's usually ice in them. There's even some clays. They find some clays in them, but they can be sort of like almost honeycombed. So yes, it's actually for us now. As we said, we went to Bennu. We've been to several others. The Japanese have been to several asteroids and comets, and they found that again they are all basically loose piles of rubble. So that's all I wanted to say about that. Is that they jigged a mission after called Stardust, which they then renamed Next, and they sent it to Tempel-1 to take these images of what they thought they were going to find a big hole, but all the stuff's fallen back inside into it, and you can. It's only just visible, really. Yeah. So that's all I wanted to say on that. So thanks for that.
Great. Thank you very much. Yeah, obviously worth following up, and we'll see what happens with the European follow up to DART. Which I think is reaching there this autumn, isn't it? If I remember rightly.
I'm not sure. Can't remember when it's getting there.
Yeah, I think it's reaching there this autumn. So there we are. Okay, so Lou has been attending AstroCon, a big astronomical event in the United States, and he's gone there in his venerable function as our roving reporter for these sorts of events, and he's now going to tell us, I hope, all about AstroCon. Lou did an interview while he was there, and because it was in a very noisy place, the sound is a little indistinct, so you may want to turn the volume up on your speakers, viewers. I'll boost it as much as I can here, but if you can't hear it, do turn your volume up, because it is a little indistinct, but it was a very noisy place to do an interview. So I hope you enjoy this. Paul says, was it Bennu where the spacecraft almost sank into the surface? Yes, it was.
Yeah.
It was a lot more loose than was anticipated. And
they couldn't close the lid on the sample.
That's right. They got far more than they bargained for, and they couldn't close the lid on the collector, if you remember. Yeah, yes, it was Paul. It was Bennu. So a bit of a bonus. And if you remember, when they got the collector back to Earth, they couldn't open it. There was a screw that they couldn't get out.
It's really stubborn.
Yeah, there's a screw they couldn't get out, and they had to build the tool specially to get this the screw out without damaging the sample within. So, but they did, and we're learning a lot from Bennu. Lou, I was wondering at some point, actually, just off the top of my head, whether you'd like to do something about what we've learned from the Bennu sample.
Well, I'd be glad to. I actually put our show in as a contender for social media content providers who are going to be at the Johnson Space Center Space Materials Environment Lab.
Ooh,
to witness the opening of the canister, the materials. And I said as many good things as I could, and about how we were going to make a whole month for small bodies and all these things. And we weren't selected, but I suspect they had some very high rolling social media there when they opened.
I'm sure. Well, thank you.
Thank you so
much. One day we'll get the recognition, I hope.
They didn't want us to overshadow the
that's
whole
right.
event.
It's NASA's loss. That's how I look at it.
NASA's loss, indeed. But thank you for that anyway, Lou. I didn't realize you'd done that. So thanks so much for doing that. Mm-hmm. And of course, you viewers can help us out. Spread the word of Space Oddities. Tell all your friends. Tell all your enemies. Tell your family. Tell their families. And help us out. Help us get some more views, and help us to move on to bigger and better things. Your support, as always, is much appreciated. So, Lou, are you ready?
Set.
Okay.
There we go. Okay. So every year, an organization called the Astronomical League has an annual conference somewhere in the United States. And the Astronomical League is an umbrella organization that kind of serves about 300 or so amateur astronomy clubs in the United States. And by the way, there was some talk at the conference about making this more of an international group. So if you're outside the United States, perhaps your club will be able to join the AL, the Astronomical League. Normally, they call their annual conference the AlCon, Astronomical League Conference. But this year, for some reason, they called it AstroCon 2025. And they had it at Bryce Canyon, Utah. I think it's in the southwest, portion of Utah. Beautiful, beautiful country. Beautiful, gorgeous skies, a really, really good place to hold the conference. And I don't remember exactly how many people were there, but I think I heard the number 400 thrown around. So there are quite a few astronomers, amateur astronomers, vendors that came to this. And my wife Susan and I traveled out there as well. We flew, so we didn't have a lot of room to carry big telescopes, but I did bring the Sea Star, so I'll show you some images from that in a moment. All right, so let's see if we can get this to move forward. All right, it is not advancing. Let's see.
You may have to go to what's actually on the computer, Lou, not this screen.
Yeah, that's what I'm doing.
And use the controls there. Should be able to do it.
Oh, come. There we go.
There we go.
There we go. Now it was listening to me. It just wasn't showing me. So let's go all the way back here. There we go. Okay.
Oh, look at that. That's gorgeous.
Bryce Canyon is, an archaeology treasure trove. This is an area that, millions of years ago was actually underwater. And so you can see a lot of striations in the hills, sedimentary rock from, effectively ancient seashores. You can go hunting for ocean fossils in the rocks, or you can just enjoy the beauty of the place. You might notice that in this picture that I took, this was from a place called Rainbow Point. And Rainbow Point is 9,100 feet above sea level. So you can look out over the whole canyon, and you can see in the upper left here, maybe you can notice some rather little bit darker clouds. That's a forest fire. And there were forest fires going on at the time, which made observing a little bit of a challenge, but we figured a way around it. So we'll talk about that.
Beautiful.
So just some more images of the mountains and what used to be an ancient shoreline in this beautiful, beautiful canyon. The red colors, of course, are from deposits of iron and iron oxide.
Did you have problems breathing at that altitude?
I did if I tried to run or walk really fast. I remember being on Mauna Kea. Now that was 14,000 feet, but and I remember trying to run about 10 meters, and no, you cannot. Here's 9,000 feet isn't that bad, really, but you can't do anything really strenuous. So
beautiful.
So not only is the scenery gorgeous, but the skies were gorgeous. Now you're going to see an interview in a few moments of a woman who says that she has a meter with her that declared that we were under Bortle maybe 4 skies. I think they were better than that. I think we had Bortle 3 skies. I mean, I just about changed my religion when I got up to point and looked up at the sky. I've never seen so many stars. So it was really great for observing. And there were observing parties every night. Some of them were public, some of them were private. And in fact, as I'll show you, there was also solar observing every afternoon. So a lot to do there. Here's just a picture of some of the fires on the right-hand side, and they would have fire update information every morning that they'd post outside the lodge where we stayed. So we ended up on a few nights traveling for maybe 20 to 30 minutes to get outside the cover of the smoke. But the point is, you could do that, and people did. Oops. So people brought their telescopes. Lots of people drove to this, even from the East Coast. They would travel for 2 or West Coast 2 or 3 days to get here. It's just so they could take their big honking trucks or vans and load their massive telescope equipment in. And so people brought some really good telescopes, as you can see here.
That's a monster there. Look at that. Look at that daub.
Yeah.
That's a 20-inch.
Yeah.
18 or 20,
Wow.
I would say.
God. Oh, look, the ones in the background are equally monster.
Yeah.
Gosh.
In lots of star parties, they will attempt to kind of group the big daubs together, and they call it something like the Valley of the Dinosaurs. Big Brontosaurus is really over everybody else. So it's just me at 9,000 feet, feeling a little woozy, but that's okay. No smoke to be had at that point, at least in that direction. The fires were going on the whole time. I think they finally, by the time we left, the fires were something like 25% contained. So they were making progress. But and by the way, these fires were believed to have been started by lightning, not by human activity. So lots of people came. Over on the upper left, me, of course, Scott Roberts from Explore Scientific. Explore Scientific just, they support financially with awards, and they always come with their equipment. So they're a strong supporter of the Astronomical League. And then on the right there, the left-hand image, the person furthest to the right, that's Chuck Allen. He's the new president of the Astronomical League. Moving to the right, Sky and Telescope was there, and this is a picture of me with Diana. Hannah Kanan is her name. She is the new executive editor for Sky and Telescope, and they're also very supportive of the League. On the far right, I forget this gentleman's name, but he works with Scott, and he's trying desperately to get me to buy this beautiful 16-inch Dobsonian. And I said, I have 4 Dobbs. I have an 18-inch F5. Well, does it do this? Does it do this? Well, no, it's a little heavier. No, I mean, and I thought about it, and I have to say, my wife has joined me in a passion for amateur astronomy, but she understands that I already have 4 or 5 Dobbs. So I think that might have been a little too much. Nevertheless,
nice instrument. It looks lovely.
It is, and it's so lightweight. That's what really caught my eye. The Dobb I have is heavy. So anyhow, that's an Explorer Scientific 16-inch f 4.5, I think. Lower left, there's solar observing out in the parking lot. Right outside the lodge every afternoon, and people brought their H alpha scopes. Some people brought their solar spectroscopes. They had the Skywatcher Solar Quest mounts that do nothing but find the sun, and there's some great imaging. I saw some in one H alpha scope, I saw some prominences that were just unbelievable. This was a Lunt solar telescope, really beautiful images. The image in the middle here, can you see my cursor?
Yes.
Okay, this is my wife, Susan. And we were just walking through this museum, kind of killing time, which is talking about the history of the canyon. We ran into these two people. This guy is a solar observer. That's what he does. I think he calls himself Solar Steve or something like that, you know. And he's worked in heliophysics outreach for a long time as an amateur volunteer, and I'd worked at NASA in heliophysics science and outreach, and so we kind of connected and shared stories. So you meet a lot of people there that are really, really cool, really nice people. On the bottom right here, this is Aaron Clevenson. He is head of the observing programs for the Astronomical League. They have a very robust observing program for all kinds of things. If you observe all the Caldwell objects, all the Messier objects, all the you name it. And he and I are working to see if we can get an observing award for eclipses in the name of Fred Espenek.
That's a great idea.
And then,
and I was going to say,
yes.
Space Oddities viewers may remember that Aaron joined us for a while on Space Oddities, but unfortunately, he was always having problems with his connection, so he couldn't do it in the end. But lovely guy.
I was impressed that he tried. He's not only head of all of their observing programs, and there are many. He's also in charge of the Reflector, I think, their online newsletter, and their web development. I mean, he just does a lot for the league, so he's quite busy. Sitting next to him is a good friend of mine, Vivian White. Vivian is with the Astronomical Society of the Pacific, and that is another umbrella group of amateur clubs. And their claim to fame, really, I think, is that they send out trainings in various topics of astronomy, as well as activities to the various clubs that they can then do with the public to explain some aspect of space science. So just all these really neat people, and people that I often wouldn't get to see, even though they're good friends, unless I go to Alcon meetings or AstroCon. So
Right.
It was a good meeting.
Right.
Well, besides friendships, there were lots of talks every day. The schedule was filled with talks. In some cases, they were science talks. Here's a talk on the upper left about type 1a supernova. This might have been, as I'm trying to remember, this might have been a talk where he was talking about the universe distance scale. I think that's right. Over on the right here, this is ZWO, and they gave a talk at the dinner, kind of the keynote speaker at the dinner. And I have to say, they have some really neat equipment. And every time I run into them, it seems to me I hear rumors about yet another C-star coming out, perhaps with larger aperture. I was unable to get them to commit to this, but I hear those rumors. There are also this on the lower left here. There's a new electronic eyepiece, it's called a smart eye, and basically you look into it just like you're looking into a telescope, but it's a digital image that has been integrated over some time, so that you get a very bright image, and it sends the image to your cell phone or tablet or whatever as well.
Wow.
This is really cool. I think its cost is not quite as cool. I forget now. It's around $2,000. And if I kind of compare that to the C-Star, it's a little different. But you do get to look directly into an eyepiece, and I think that's part of the benefit there. On the lower right, there were a few talks on beginning through advanced astrophotography. And Roger, I was thinking of you, either that you would have loved to be there or you would have loved to give those talks.
Oh, yes.
Different equipment was discussed, different software and different image processing techniques. So I sat through a couple of those, and those were very interesting.
Wow.
Here's the solar observing. I think they had solar observing from something like noon to 2 every afternoon. It was always clear. In the upper right here, in the upper right here, this is a solar spectrometer. You can see the Fraunhofer absorption lines by looking through the, somewhere in here. Where do you look?
That's clever.
I forgot. Well, there's an eye. Here it is. I'm sorry. This is the eyepiece. So you look in here, and you can adjust the center of this, the spectral range that you're looking at, and you can see the Fraunhofer absorption lines, which are evidence of the different elements in the sun's corona.
What a cool idea.
Yeah, you can buy this thing. I mean, I don't know how much it costs, but it's commercially available. And of course, people brought their hydrogen alpha and regular scopes. I set up my C-Star for a while, and that was kind of fun, but it was really bright outside. You know, even here we're at 7,000 feet. And so I had to, every time I wanted to show the image, I had to usher people over into the shade so that I could show them my cell phone. But, anyhow, solar viewing we had. So these were some of this was the area. This was a place called Ebenezer's Bar and Grill. I mean, you're in cowboy country here. People walking around with spurs. You know what spurs are?
Yeah, of course.
Where to kick the horse.
Yeah. And
chaps, which were leather coverings on the legs for people who ride horses, and big cowboy hats. I mean, it's cowboy country. And
yeehaw!
There was a night, I guess it was the dinner, the special dinner. There's always a special end of the conference dinner, and it was very good food and all that. And they had a show, which was country music.
Oh dear.
Oh dear. And it was right up on this stage here. They used this place for a whole bunch of things. And so we, some people loved it and were clapping along and yee-hawing, and Susan and I were listening politely.
Did you do any line dancing, Lou?
Yeah, I will ask you to shoot me before I ever do a line dance. Susan and I have gone out. We do ballroom dancing. We learned waltz and swing it, but I will not line dance. Okay. On the right here, let's see. This is a gentleman that had a really nice setup, who's talking about how to use the ASI Air. And I had some questions about that since I use the Air. And he's got a electronic focuser. He's got his ZWO camera, his ZWO mount, and there's his finder camera. And he's got ZWO everything. He might have been a vendor. I'm not sure. The other thing that was really cool is they have the best door prizes. Oh my goodness! I mean, they gave away a few C-Stars and other robotic telescopes and big binoculars, and oh my goodness, they had great door prizes. I didn't win anything, but it's okay. Next time.
Yeah.
So I mentioned we went out observing. I got out 2 nights to observe. One, we just drove. So the fire's over there, we're going this way, and we drove until we went to this desolate country road. There are no lights, there are no people, there's no anything. We just pulled off the side of the road, and I was with Aaron Clevenson, head of the League's observing programs that I showed you. And he and I set up our sea stars and we started observing. Now they had a contest going. If you could observe 20 of the items on their list, or photograph 20 of the items on their list, you'd win a bronze prize, and 30 items you'd win the silver prize, and so on. So Aaron was anything, as long as he could get something registering on his sea star, he'd stop the observation and go to the next object. I wasn't as interested in the observing program, so I had longer integration times and better images, but the skies were great. And so these are some of the images from the sea star. This is the first, on the lower left, that's the first image of the Sombrero Galaxy I'd ever taken.
That's pretty good, isn't it?
So I want to try a much longer integration time if I ever see clear skies again. Right now I'm under thunderstorms here in Maryland. But anyhow, so that was fun. Okay.
Wow.
Let's see.
Yeah, that Trifid nebula is fantastic.
Yeah, I mean, when you're up at above, I don't know, good percentage of the atmosphere and it's clear, and oh my goodness. So what I'm going to show you now are two interviews that I did, one with Scott Roberts from Explore Scientific, and one from a representative from the Westminster Astronomical Society. So I'll just play these.
Right. And as I said, viewers, you may need to turn your volume up a bit for that. I'm going to try and boost it here as much as I can, but let's see what happens.
And I think I've got, yeah, here we go. I've got, let's bullshit all the way up there.
Okay.
All right, let's see if you can hear this. Here we go. Well, hi, Space Oddities fans. We are here at AstroCon 2025, one of the largest assemblies of amateur astronomers, at least in the United States. They have vendors, they have workshops, talks, star parties, barbecues, everything you could imagine. And we're here today with Scott Roberts from Explore Scientific. Scott brings his exciting telescope wear to every conference, right?
Well, not every conference, but we do feel that the Astronomical League is a very important organization. They are the world's largest federation of astronomy clubs. I think over 300 clubs or something, over 25,000 members, okay? And it goes back to maybe the 30s or the 40s, something like that. I think they celebrated 75 years recently, so a really amazing organization. All their awards, their observing programs that they have, and kind of the legacy that they carry forth, and breathe life into our whole amazing community.
You bet.
Yeah,
and
so we like being here.
I know you and Explore Scientific are big supporters of the league.
We try to support the community that supports us, so we feel responsible.
Outstanding. You were mentioning so the league is maybe 75 years old.
Yeah.
A lot has happened in 75 years.
Yeah.
In telescopes and technology, observing.
That's true.
What do you see happening in the state of the art?
Well, the state of the art now is integration of different technologies. Of course, there's great glasses out there.
Whoops. Let's see what happened.
Around for a while.
Here we go.
You find old telescopes that have wonderful optics, but then they started incorporating electronics, and then they, I started with all this back in 1980. So I knew some of the old guard and learned about, some of the early electronics for amateur telescopes. Professionals have had stuff always first, but amateurs always followed, to incorporate in their amateur scopes. But computers are deeply ingrained in telescopes, all kinds of amazing things. I mean, can you imagine having a camera like what ZWO sells today back in, let's just say 1990? Okay.
It would have been unheard of, magic.
Yeah, right. And so it would have cost a fortune. Okay. So the whole practice in the amateur astronomy industry, or telescope industry, is taking like $1 million technology or maybe multi-million-dollar technology and reducing it down putting it into a scope that might sell somewhere between, I don't know, $500 and $2,000. You know,
Right.
so
So the gap, in a way, the gap between professional and amateur astronomy is closing.
yeah, and you know that. I mean, because you've been in the professional world for a long time. Yeah, but you're very ingrained. That's what is so exciting to meet someone like you, because you're so involved in the amateur community as well. And so I had a conversation with Diana over at Space Telescope just this morning, and we were talking about the just the whole community of professionals and amateurs. And there's all kinds of more and more, anyways, citizen science programs. And I think you're involved in a lot of those.
Yeah, NASA especially has really gotten involved with citizen science. Although it's a little different with NASA. Officially, I think NASA headquarters has said that citizen science is publishable research that you, as an amateur, if you're supporting professional observations or collecting data or doing data analysis, you could even have your name on the paper.
Right, I've seen that.
And there's a lot of citizen science that is not publishable. It's replicating previous results, which I think is very valuable as well.
Right, that fortifies the original observations or whatever. So,
Right.
very good. You know, but from a telescope maker standpoint, it is exciting for us to make a telescope and have our client or customer call us up and say, hey, I saw whatever, you know, I saw this, what they're going after now is T-core board, T-corona borealis.
Waiting.
Yeah, I expect that it probably will be an amateur because they're out there watching all the time, okay, to see this outburst happen. And so, you know, whoever's telescoping, or whether it's an observatory or whatever, it's going to be a magic moment. It's going to be very exciting, and amateur astronomers that will learn about it and run outside with their telescopes with visual level magnitude star erupt. You know, it's going to be
Incredible. And of course, they'll be involved as the light curve drops.
Yes.
Amateurs all over the world will be watching and collecting data, so that's right. That'll be really important. And you're here. I mean, speaking of these amazing, you're here with a whole suite of telescopes that some of them you couldn't even have imagined 10 years ago.
Oh yeah. So we talked a little bit about the technology of telescopes and where that went. You know, when I started, you know, having a Dobsonian telescope, that was all the rage at the time, right? And that's how I learned the sky really, is with the Dobsonian. But I watched the digital revolution happen with companies like Santa Barbara Institute developing for the first amateur affordable CCD cameras and stuff. And then, wow, that just kept increasing. Software developers that are out there, you know, making it possible to track and stack images and really tough things that pros did, okay? But now the amateur can collect a bunch of images and go, and it does a number of things quite automatically. But you know,
I've often thought it would be great to have a segment on Space Oddities where we throw up two images.
Okay.
And say, is it Hubble or is it backyard telescope?
Oh, there's a lot of guys that love to do that.
See if you can tell the difference. I think they're getting.
Oh yeah.
They're getting close.
Sure. So you look at planetary photographers like Christopher Go, okay? He uses, I think, a 14-inch celestron in the Philippines, and he does benchmark his planetary images against Hubble, okay? And works as an amateur with the Hubble too, you know, so I mean, you can't be a brain surgeon, you know, amateur brain surgeon, and coordinate activities with professionals. Yeah,
It's just getting crazy.
I thought I'd throw that out there, but there's no other community that I can really think of where professional leading edge researchers interact with amateurs or just the interested public. You know, so and you know, so I brought this up with Diana from Sky Telescope, and she was talking about the love of astronomy and the wanting to share information. information. So, and
You at Explore Scientific are paving the way and making this.
well, we're certainly cheerleaders for all of it. So, you know, yeah, we try to support amateurs, beginners, pros even from time to time. But it's great to be invited to the show. You know, we'll talk about it. So,
Well, I get to sit here in the Explore Scientific booth. I mean, what could be better for me? Well,
for me, yeah, Blue Mayo in my booth. Okay, so.
okay, mutual admiration. Yes, that's right. Well, Scott, thank you so much for being here with us today and for your support of the Astronomical League.
Thank you. And you guys join the Astronomical League. Keep looking up and follow Lou Mayo in this program.
There you go. Okay. Do we have time for another interview?
Certainly.
Okay, let's do the next one. We have one more. There we go. It's a funny expression I have. Let's play this. Greetings, Space Oddities fans. We are here at AstroCon 2025 in Bryce Canyon, Utah, and I'm speaking with Laurie and Sorge from the Westminster Astronomical Club. Came here all the way from Maryland. I don't know, why would you do that? It's a long drive, and there are no direct flights, are there?
I didn't even check because checking telescopes into the airlines to get here under dark skies could be a bit of an issue.
That's right. Did you drove?
We drove.
Oh, that's right. I remember. Wow. So you have some great equipment here.
We do. Husband's testing out some astrophotography gear, and I'm putting some smart telescopes to use.
Wonderful, wonderful. So you're with the Westminster Astronomical Society?
Yes.
WASI.
Yes.
What's the I for?
Incorporated.
Incorporated. Okay.
Yes.
And what's your role with WASI?
Wow, what isn't it? I'm the treasurer, and I also do a lot of outreach. I do the membership. Basically, we ended up taking on a lot of roles at the end of for us in the middle of COVID because there was a need, and our membership had dropped off. And helping the little CPR, have a little organizational development background, but I'm also a lifetime member of Astronomical League, so I'd like to help them out too.
Okay, and WASI is a member of the league as a club.
Yes, it is.
Yeah. And as I remember, it's a pretty big club, isn't it? A couple hundred members?
Well, yes, at the height of COVID, though, it did drop to about 40 or 50, and at last check, it was hovering around 200.
200 members. That's a big club.
It is. And so we just completed a process of going through a strategic plan to make sure that we're engaging our members and providing what it is that we need going forward so that we have sustainability.
Outstanding. Wow. And so you're all the way out here at AstroCon. Why do you come to AstroCon?
Well, first of all of the Astronomical League conventions are a fantastic place to meet people of like mind. And anybody you meet, you see them in the future AstroCon or Alcon, they end up being life members, and you end up tracking how they're doing, exchanging ideas, reaching out when something comes up like eclipse for resources or advice. So it's number one, the people, and number two, if we could pass up an opportunity for some really good dark skies, even with the fires going on locally, it's been great skies.
Right. So there's some forest fires in the area, and the winds are kind of blowing them around. So but you still have managed to find some really dark skies.
Yes, the first 2 nights here, the winds had changed direction after dark, and luckily it blew the smoke away and settled it down into canyons. I do have a sky quality meter, and I did clock in the skies at Portal 4. And last night was also Portal 4. And the last 2 nights were borderline pushing 3. It was like within 5/100ths of a point of hitting Portal 3. Now, keep in mind, with the forest fires, there's a lot of particulates in the atmosphere. In fact, some people have even seen ash raining down at times. Yes, the firefighters are keeping it away, and they're doing a fantastic job, and we're grateful for them. That particulate in the atmosphere does cause some, whatever little light there is, some reflection, and that will have an impact on your sky quality. But I can tell you that for everybody that I know who's taken imaging here, it's still, unless they're living under Boreal 1 or 2 skies anyway, far and above better skies than they've had back home, and they're all very loud.
And you were up at Rainbow Point last night, right?
Yes.
Kind of, even though it was pitch dark, somehow we kind of ran into each other. What would you? So that's at 9,100 and some feet.
Yeah, the sign I saw, or the thing that I saw, and I did try to get my device to tell me that. I estimated about 8,800 feet there.
Okay.
Which I'm told is about 25% less atmosphere that you have to look through as well.
And so what would you call the skies? So as I was looking around, I said, okay, I can see every star in the Little Dipper. And I'm sure it was even better than that. What would you call those skies? Are those Boreal 3 skies? Or?
Well, the actual measurement on it was a Boreal 4 using an SQM, which is a sky quality meter. Back home, because of the light pollution under our Boreal 5 skies, I typically will use the number of stars in Ursa Minor or Little Dipper to give me a judge on the transparency for the night. So I may have 1 or none if it's a really bad night, or 3 or 5. Typically, it's an odd number. When I get to dark skies, like here or some other places we've been, of course I'm going to have all 7. And there are ways to then count the additional number of stars. It's not too often I've had to do that, but yes, there are a lot more than the typical 7 bright stars, and there's a major here.
Right. As I remember, you do something I've not heard of before. Correct me. Observational digital observing. Is that? Did I get it right?
I did not coin the term, and I do have a slide deck where I do give credit where credit's due. So forgive me for not remembering who coined it. I'm neither an astrophotographer nor totally visual. I'm in this niche that's emerging called observational astrophotography.
Okay.
So I enjoy the astronomical league programs where they have a list and you can earn points and certificates. And it's typically 100, 125 objects to find. I like, because of my background in photography, being able to at least have a snapshot, a souvenir, better than my drawings, of what it is I saw. So using smart telescopes, I can take a short exposure and take all of my log notes on site while I'm doing my observing, but then also have those pictures to go back to and do a deep dive on later. I really love having my own personal digital photo album to go back to and refer to. And then it's especially useful, like I think M60 had a supernova a couple years ago.
M60.
It's a galaxy. I was able to do some comparisons and also over time watch the supernova fade. So when you have a little personal library like that, you've got some better references to go back to. That's why I really love the quantity of the photos versus the hundreds of hours of digital data gathering and then processing time that some of the astrophotographers really enjoy.
Wow, you're a really committed observer. I can tell you've got your logs set up and all of that. And you also went to some of the talks here at AstroCon.
Oh yes.
What did you learn?
There's always something to be learned, and the interesting thing about AstroCon is, or even Alcon, is that the title of a talk isn't always the full breadth of what's going to be there. There's always some nuggets, no matter what, that you're going to learn. This time around, I got to see what Chuck Allen, our Astronomical League president's logs look like. And I happen to know that he still uses 3x5 cards because he started that way. And
old school.
Yes, very old school. But seeing how other people approach it and their data and how they're able to go back to things is invaluable, because I'm always switching it up, trying to find the best way to be able to go back and reflect on what was the moon like that night, kind of a thing, for example. But all of the sessions have something beautiful. In fact, Chuck gave up half of his time to the whole kind of winner this year. A young fellow, 17-year-old out of I'm going to miss it, but it's in one of the Midwestern northern states, and he was just awe-inspiring. I'm a beta tester, volunteer with Stellar, trying to make sure that their app deployments are very good. and he was using the unistellar for citizen science. And that's how he won his award, and where he's going with that is just gave me chills.
And is he giving a talk tonight, or did he give a talk today? Is he on the docket?
I don't know if he's on today, but Chuck gave up half of his time on logs and whatnot to this young fellow yesterday, and his presentation was just so polished. In fact, he had some colleges, representatives from colleges, passing him cards afterwards, trying to recruit him. So that's the impact that he had on folks.
I know the Astronomical League has done wonders with promoting astronomy for young people.
Yes.
And Westminster Astronomical Society also encourages young people in your programs, right?
Yes, we do.
Do you have special programs for them, or do you just invite them along on star parties?
They're invited to everything, as they're even though we have a discount for youth membership, they have full rights. I know that some of them have some service hour requirements for their schools, and they're able to fulfill that at outreach. We sign off on that. We haven't had enough young people that are interested in coalescing into a separate youth program yet. Maybe that's something with your background on youth that you're interested in jump-starting. But we do have some very, very interested youth that are totally into the hobby that would probably welcome that.
Outstanding. Well, obviously we have a few things to talk about.
Oh, yes.
Well, Lori, thank you so much for being with us on Space Oddities. I really appreciate all that you're doing with the Westminster Club and all that you're doing with amateur astronomy. Thanks so much.
Thank you. Appreciate your time.
Okay. Greetings,
Whoops.
Space Oddities fans.
Let's see if we can stop sharing here.
Great. Well, thank you very much for that, Lou. Some great people you interviewed. They're really interesting.
The amateur astronomy community has a lot of really great people, not just passionate about what they do, but just really nice people.
Yeah, absolutely. Absolutely. Well, I hope you will go to similar events as our roving reporter and keep us up to date with what's going on. And, particularly as we keep saying, the technology moving on so fast that, as you said, there were instruments there that would have been unthinkable just, probably even just 5 years ago. It would have been unthinkable that not only could they exist, but they could be within the range of the budget of amateur astronomers. It's incredible. It's absolutely incredible.
It is. And I'm already looking at my schedule for Stellafane, which will be in the fall. A biggest astronomy meeting of telescope makers in the country.
And where is that being held this year?
It's in Springfield, Vermont, I think. Every year, same place every year.
I'd like to pop over. I really would. I'd love to go to something like that. I really would.
Come on over to the dark side. Come on over.
Yeah. Well, we'll see. Anything's possible. Anything's possible. All right. Well, thank you so much for that, Lou. Thank you so much for making the effort to interview people on behalf of Space Oddities. And glad you had a fantastic time in a beautiful place. So there we are. Okay, let's move on now, because I think it is finally time that we heard something from Michael. No?
Oh,
yeah.
hello.
So,
I'm here.
okay, so it's time for our regular feature Constellation of the Week, and we're going to follow that up last thing this evening with Einstein of the Week. So, Michael?
So just bear with me while I get my screen sorted out.
Certainly.
Okay, and then I'll go there, and I'll go back to your screen, and then I'll do, which is share screen now? Share screen, there it is. Window, and it's that one. Okay, can you see that?
We can indeed.
Okay, so tonight's Constellation of the Week, we're going to look at Ursa Minor,
which Lou was talking about earlier.
which he was definitely, yes. Often overlooked, but very important constellation, because not only because of the mainly because of the location of Polaris. I'll come on to that in a minute. So we explore the night sky's most crucial constellation, Ursa Minor, or the Little Bear, from its ancient mythological origins to its vital role in navigation across the centuries. So this is an old drawing of the Little Bear on the right here, surrounded by the Draco Serpent constellation. It's another one we'll have to do at some point.
Yeah.
But Ursa Minor, also known as the Little Dipper in North America, has been recognized since ancient times, featuring predominantly Greek mythology. According to legends, Zeus transformed his lover Callisto into the great bear, Ursa Major, and her son Arcas into the Little Bear, or Ursa Minor, to protect them from his jealous wife Hera. The Phoenicians were among the first to use the constellation for navigation around 1500 BC, recognizing the value of the relatively fixed pole star. Later, both Greek and Roman sailors relied heavily on the Little Bear to navigate in the Mediterranean. Ptolemy catalogued Ursa Minor in his astronomical treatise, the Almagest, in the 2nd century, cementing its place in Western astronomy. The constellation has been depicted in star charts and celestial maps throughout history. And so this is the diagram shows the Ursa Minor with Draco looping around it. This is in a set of constellation maps published in London in 1825. Okay, northern circumpolar position. Ursa Minor is circumpolar in the northern hemisphere, meaning it never sets below the horizon for observers of north of 41 degrees latitude. It rotates around the north celestial pole, appearing to circle Polaris throughout the night. You will have seen lots of star trail images of stars going around the pole. This is just an example of one of those images. So quite a fascinating type of image, I think. Okay. The easiest way to locate Ursa Minor is to first, find the more prominent Ursa Major. The two bright pointer stars in the bold of the Big Dipper, in the diagram here on the right, these two here, are Dupe and Merrick, form a line that points directly to Polaris, the brightest star in Ursa Minor. It's there. The Little Dipper pattern is now also known as the source band, with Polaris at the end of its handle. This asterism is smaller and fainter than the Big Dipper, but follows a similar shape. But just put a cartoon of a little saucepan just to demonstrate that similarity. Okay, so just a few notes on the main stars. We have Polaris, which is magnitude 2, located just 0.7 degrees from the North Celestial Pole. It's a multiple star system dominated by a yellow-white supergiant, approximately 430 light years from Earth. Then we have Kochab, or Beta Ursa Minoris, magnitude 2.1, an orange giant star about 130 light years distant. Almost as bright as Polaris, it forms part of the bowl of the Little Dipper. And then Perhad, or Gamma Ursa Minoris, magnitude 3, a white giant star approximately 480 light years away. Together with Kochab, it forms the Guardians of the Pole. I've not come across that one before.
No, I've never heard of that.
No. So Polaris, the brightest star, is a yellow-white supergiant, actually a multiple star system comprised of the main star Polaris, also known as A, capital A, small a. It's also a Cepheid variable, and it has at least two smaller companions. although commonly believed to be directly over the North Pole, Polaris actually sits at 0.7 degrees from the true north. Despite this slight offset, it appears virtually motionless in the night sky, whilst other pole stars rotate around it.
And the other thing about the pole star, I come across lots of people who expect the pole star to be something really bright and
that's right. Yes, definitely.
But of course, it's not.
Yeah, people think that the pole star is the brightest star in the sky. It's not.
Yeah, it's not. No.
But some of you may know that the Polaris hasn't always been the North Star and won't remain so indefinitely. Due to the 26,000-year precession cycle of Earth's axis, other stars have served as this role throughout history, including Thuban, Alpha Draconis, around 2600 BC, and Vega, Alpha Lyrae, which will become the North Star in around 13,000 years.
Can't wait.
Yeah. And the Earth's actual precession is a slow wobble of the Earth's axis rotation, taking roughly 26,000 years to complete one cycle, shown in the diagram here. So, yeah, it won't be the pole star forever. Okay, another diagram of the pole star Polaris, showing the companions. Polaris A on this diagram is on the top left here. Polaris B is quite a long way away, but this image on the bottom is a Hubble Space Telescope image, and resolves the close companion Polaris AB. So it's a multiple star system, at least 3 stars in that system.
Wow.
And the outer pair AB was discovered in August 1779 by William Herschel.
Herschel strikes again.
Yeah, he does. Okay, so there's not many deep sky treasures within some minor, but let's go through them. NGC 6217 is a barred spiral galaxy approximately 67 million light years away, with an apparent magnitude of 11.2. It's got distinctive spiral arms and an active galactic nucleus, again discovered by William Herschel. Okay, also NGC 6251 is a giant elliptical radio galaxy approximately 340 million light years distant. Active galaxy features a supermassive black hole at the center, and a remarkable jet extending over 200,000 light years from its core. And another galaxy, a dwarf irregular galaxy, UGC 9749, approximately 22 million light years away, discovered by A.G. Wilson from the Lowell Observatory during the Palomar Sky Survey of 1955. So one or two things, but not necessarily amateur targets, I don't think. Okay, and finally, celestial navigation. Phoenicians sailors were amongst the first to rely on Polaris for navigation around 1500 BC, recognizing that maintained a nearly fixed position whilst the other stars appeared to move around it. During the 15th and 17th centuries, European explorers used cross staffs and astrolabes to measure Polaris' height above the horizon, directly revealing their latitude. This technique enabled global exploration and the creation of increasingly accurate nautical charts. Even with modern applications, with GPS, celestial navigation using Polaris remains an essential backup for skill for aviators, mariners, and military personnel. And even modern cruise liners, the bridge staff had to know how to use sextants and other manual navigation instruments to just in case the whole system goes down. They got a backup basically. Okay, and that's about it. Thank you very much.
Thank you. Thank you very much, Michael. Well, there you have it. Constellation of the week. Big thank you to Paul Burkhardt, who's just signed up to become a Patreon member. Thank you very much, Paul, for your support. If you have any questions, you can always email it at we actually got a special email address for our Patreon members. It's rather predictably patreon@spaceoddities.space. So if you have any questions, Paul, and anybody else who joins up, then don't hesitate to drop us a line if we can help you at all. So don't forget, just to go over that again, join our Patreon, which is patreon.com/Space Oddities. Not only do you get the presentations that we give you each week, we will be giving you stuff that we don't show here. For example, there's already a presentation up there about the history of the telescope, which we hope you'll find interesting. Lots of other stuff to come, lots of videos. So join up and support us at Patreon. It does cost £5.50 a month plus VAT for that. But in return, we will not only give you the aforementioned goodies, but as a present for joining, we will give you 2 lovely 10x8 astro photos taken by Lou, by Daz, by Roger, and by Tom. And full instructions on how to claim those are in the chat called for new members in the Patreon page. So help us keep Space Oddities going, and thank you so much. All right, we're going to finish off this evening with, it's time again to delve into the nether regions of social media to find out what people are saying about the universe. So it's time, in short, for Einstein of the week.
Hey,
so just let me sort this out. And I'm afraid I haven't got many this week, but there will be more next week, I'm sure. I hope you can all see that. Daz, if you could just maximize that to get rid of the ugly mugs, that'd be great. Okay, Einstein of the week. So firstly, this is a lovely James Webb image of 2 colliding galaxies. You can see that there's a lot of interaction going on there between 2 galaxies. Now, huge diffraction spike on that because it's a bright target, and those diffraction spikes are caused by the struts of the secondary mirror assembly on the James Webb Telescope. Nothing we can do about that. But more interestingly, somebody came up with a rather interesting question about this, and the question they wanted to ask about these colliding galaxies was, is there an estimate of lives lost, missing, or injured? Yes.
My.
So,
is there? I mean,
yeah, make of that what you will. That's beyond my comprehension, I'm afraid. But we can assure you that no humans at all were lost, missing, or injured during the collision of those galaxies. Second one. Here's a task for you, team. Describe planetary moons in 4 words. Define planetary moons in 4 words. Anybody want to take that challenge on?
Satellite. I don't know. Come on.
It's around a planet.
Okay.
That's good. Good.
That's very good. That's very good. Somebody on Facebook.
Satellites orbiting a planet.
Yeah, very good. Very good. Somebody on Facebook came up with a lovely definition. All are fallen angels.
Oh.
Sad.
Oh no.
Yeah.
It breaks your heart, doesn't it?
It does break your heart. Lovely. And then we have, now, here's a question for you, team. What is this a photo of?
Spot Wally?
U.S. astronauts, many of them have been to the moon. I don't know if all of
Were
them.
the Apollo astronauts?
1, 2, 3,
No,
4.
there's too
24.
many.
Yeah. No, it is in fact all astronauts that have been to the moon.
Okay.
Yeah. And
of course, we forget the 8 and that, don't we? Yeah, sorry.
Yeah, absolutely. So these are all the guys that have been to the moon, either to land on it or to orbit it or go round it. So there we are. But somebody on Facebook wanted to know something particular about these people. How many are Freemasons?
What?
And now the thing is, I'll tell you where this comes from. It's one of these loony conspiracy theories that all astronauts that have ever been into space are Freemasons, and they're all part of a satanic Freemason conspiracy, and that's why they're asking the questions: how many are Freemasons?
Do you mean we're being conned?
Well, possibly. I did answer this guy because he did ask a question, and I did look it up, and only 3 of them are known Freemasons. So that just killed that conspiracy theory stone dead. So there we are. And that's it. That's the end of Einstein of the week. I'm afraid not many this week, but I hope to get more next week. So there we are. There are some weird people out there, aren't there? Let's face it. I love the one about the four.
Can I just add to that? Talking of Apollo,
yes, of course.
Next week it's the 50th anniversary of the Apollo-Soyuz test project.
Is it really?
I remember that.
Yeah, I remember that.
The last use of an Apollo spacecraft.
Yeah, indeed. It was in the era of détente.
Détente, right.
Yeah, absolutely.
Yeah. So,
Also, Michael, I think it's only fair for you to mention the latest edition of Capcom, is it not?
Yes, the latest edition of Capcom is out. That's available free. If you want to receive a copy, just email capcom@spaceoddities.space and ask for your email address to be added, and I shall add it to the mailing list. So,
for those of you who might not know what Capcom is, it's a free magazine as a PDF that Michael produces every 2 months. And it's always nothing less than excellent.
Okay.
And, the latest edition is really good, as ever, Michael. If you want to learn more about Capcom, then you can find out more about it on the Space Oddities website, which is spaceoddities.space. But as Michael says, if you'd like to subscribe, then please send an email to capcom@spaceoddities.space and you'll be added to the list.
Yep.
So there we are. So we do give you lots of lovely freebies here on Space Oddities.
Yeah.
You're a great audience, and we do appreciate you, and we always want to show our appreciation.
And of course, as well, as a bit of a plug for Capcom, if anybody would be interested in producing an article or 2 for Capcom, please do so. Send it to me. Anything will be considered. Any kind of spaceflight astronomical articles are considered. But please send it again to capcom@spaceoddities.space.
Yeah, thank you, Michael. That's great. And talking of freebies, don't forget I mentioned that if you join our Patreon, you get all the presentations from our live streams. What I didn't point out was that they are PowerPoint files, but they're .pptx files. But that's the current format of PowerPoint since 2007. So unless you've got a really, really old version of PowerPoint from before 2007, you'll be able to view them. We hope you enjoy them. Comments, suggestions, feedback, as ever, you can put in the chat on Patreon called Astro Lounge.
Thank you for that, Paul.
Special feedback there.
Yeah.
And Paul says Capcom's always interesting. Thanks for producing it. Well, thank you
for
saying it. There we are. We'll give you the money later, Paul.
Yeah.
So there we are. All right. Well. Yes. I think that brings us to the end of Space Oddities for this evening. Thank you so much for being here. We'll be back next week with more stuff. Not quite sure what yet, but we will be back with something. And we thank you so much. And don't forget, join the Patreon, support Space Oddities, get loads of freebies. What more do you want out of life?
Yeah.
So I'd like to thank all the guys here. Thank you, Michael. Thank you, Lou. Thank you, Daz. Thank you, Roger.
Thank you all.
For your contributions this evening. Thank you, our audience. Have a fantastic week, everybody. We'll see you back here at the normal time, 8 p.m. UK, next Tuesday evening. And have a fantastic week. look after each other, be good, and if you can't be good, be average. That's what I always say. So there we are. All right, we'll see you next week. So from all of us at Space Oddities, have a great week, and we'll be